Okay, today I'm going to try this solar panel on the battery. It's a fair way away, so we have like 0.1 of a volt drop out of that solar system. I'll hook it up to the data logger. It is at 7 or 6 volts or something. I'll connect the data logger. Okay, that's the battery voltage at the moment after that discharge 2 days ago. We'll set our load to 100 milliamps and a cutoff voltage. The voltage could be too high on this cell, but the milliamp draw's not too big, so it might compensate, or there might be a voltage drop, or it may not even work. So right, I'll start the monitor and I'll connect the other end of the lead, if I can find it, black one. Okay, connecting now. Alright, we're at 1.9 volts, which ain't too bad actually. That's from the solar cell, and 100 milliamps delivering from the solar cell. So I'll leave it on charge. I might have to move this panel later on, if I'm still here. I think where it is, that gets sun most of the day, so I should be alright. So I'll charge it up and see what happens. Oh yeah, we're increasing in voltage. So it was 7 volts or something. No, I had to change it because it broke off again, so I had to, I lost that top wire, so I brought it down to the second wire on that panel, and that was 6.5 or something volts without load, and it was 130 something milliamps without a load on a short circuit, but we're only drawing 111 milliamps from that panel and 1.9 volts. So it drops in voltage when you connect it up a bit. Yeah, just out of interest, and then I can save my no power. I got free energy. Woo! Yeah. Alright, I'll be back. My electrode mesh has just came 316 stainless, it's 5 mesh. I'm going to put that through the carbon and make the flat plate. I've been waiting 3 weeks for this little beauty. It's A4 size. I should get 4 electrodes, I think, out of this. Hopefully, 4 or 3. They're going to be about that big. Hopefully it works. Excellent. Can't wait. I've been waiting for a long time. Okay, I'm finally getting to use the mold I made a year ago or something like that. I've tried it before without the stainless and they just collapse after they dry out and they become brittle. So hopefully the stainless will act as a contact through the center of the carbon, and we will be able to attach our ends to this side. And yeah, I should easily get about 4 out of this. So here goes. Okay, it's better than I thought. You get 7 of these little buggers out of the A4 sheet, so that's good. I got another A4 sheet in there, but I've only got enough carbons to probably make about 4 electrodes. I think the little mesh will sit in there. I'll lift it up slightly, so it's in the middle of the carbon. This mold will take 50 grams of carbon to fill it to the top. There'll be 50 grams of that carbon, the redhead carbons, 50 grams of the dextrin, which I added vinegar to it before I put it in the oven. It surprised me, it goes really hard, like you've got to mix it in still and break it up, then put it in the oven and stir it, and it turns into a silicon looking and smelling substance. Then eventually it sort of dries, and didn't get it completely. There is white bits, but that won't matter, they'll burn out. So this is dextrin, corn flour mixed in vinegar and then heated to 400 degrees until it's turned all brown. And the vinegar might help activate the cell, because you can still sort of smell vinegary smell in it. So I'll be using that as the binder. It's not waterproof. It will have to, once this dries and sets into the molds in the carbon, it will be activated again in the furnace at 1000 degrees for 4 hours. and that should turn it into that. I think with these, because these are made in Indonesia, I reckon they will use a cornstarch. So if I don't get sort of the same results, I'll go to a cornstarch for the binder and do the same. Because it could be the cornstarch in the carbons having something in the furnace at high temperature, which makes it go so well. And the little cell's been on charge for an hour and 30 minutes. We've hit 2 volts now, and we're still stable at 111 milliamps. But it's good, the voltage is actually increasing. So there's no bubbling and no hissing because we're down on our voltage. So I'm not sure how the cell will run on a low volt charge, but it should still function and probably last longer doing it like that. And plus I don't have to run my power supply then, which is a win. Alright, I'll be back with the update. Fingers crossed on my carbon mix and holding together on that stainless. It's 316, and hopefully it fires well and the 316 doesn't crack the carbon when it's in the furnace. Ugh. Which is all sorts of issues, so yeah, bit of luck. If that fails, I'll probably have to go to that type and make a mould up in a bit I'm going to probably go for a 200 or 250 mil high version of it with a larger center hole and try to compact it like that. Okay, I'll be back. Okay, I'm going to use those pieces of carbon. They're the same carbon already activated to hold the stainless in the center of it. They shouldn't really matter. They should just bond anyway, and this piece here will just break off anyway because I'm going to leave it open to attach the well, that's if I can, if it doesn't run, because it's a bit runny. I make it pretty runny. Got 50 grams of the dextrin, and I'm going to mix it with I think 50 to 100 mils of distilled boiling water should work. I'm just waiting for the kettle, and I'll mix that up, then I'll mix my carbons and I'll pour it into the mold. Okay, 100 mils of water wasn't enough, so I'm going to go 200 mils, and that should dissolve that into a syrup, I hope. Okay, 30 minutes of stirring and we get a nice thick syrup. So 200 mils of liquid. I've got my 50 grams of carbon already in that cell. I just ground them up, the rest of the pieces up, down in there. And I won't use all of that liquid, I'll just make that a runny paste, just so I can pour it into the mould and set. And you've got to keep it out of the sun or the top of the mould will crack, I've discovered. The other test pieces I was using to mix it up, they failed. They cracked through here without a stainless thing in it. Measured like about, what was it, 40 ohms over that area, unactivated. So that's not too bad as a binder, but you can't wet it. It will dissolve and it'll just turn into paste again. I'll be hoping that when I activate it in the furnace at 1000 degrees, it will form carbon bondings, which will sort of mimic those other cells, and it should hold together and be waterproof with lots of pores all the way through. Okay, I'll mix it up and pour it in. Okay, I got it poured. I went right over the electrode, doesn't matter. I thought it'd hold together. We can just cut it through and break it off and expose the wire. Okay, it took a bit less than 50 grams, but I put the carbon into the mould without the piece of stainless. So what we have left is probably 2 spoons, and that's the consistency of it. And I only used around about 100 mils of the binder, so I'll put some water in here so it doesn't dry out over a couple of days, because that takes like at least 24 hours or more to come out of that mould. It shrinks and it frees itself. I got baking paper on the bottom, and I'll cap that, and I'll use that next to make the next cell. So fingers crossed that we get a pretty good cell. And for this cell's charging off of the solar panel, we're slowly increasing. We're gonna sort of reach 2.1 volts soon, I hope, and we drop down in milliamps slightly by 5 milliamps. I don't know, 0.0, yeah, something like whatever. Yeah. So I'll keep it charging up because it's only on a low charge, and we'll see how it actually performs on a solar panel. Okay, I'll get back sometime tomorrow or whenever I release this. Oh no, actually I'll get back when I start the run cycle of this. So yeah, too many jobs going. Okay, I'm back. The cell's been on charge on a solar panel for 7 hours now, and it was rising until around about probably a half hour ago or something like that, and we're slowly dropping in milliamps. We started off around about 115 milliamps or something coming out of the solar cell. So I'll just disconnect the power and we'll do a discharge. I don't know how well the cell's going to go at that power. It's holding 1.8. I'll just change the other ends of the data logger. Okay, so we're a little bit down. Oh no, there we go. We're 1.8. I'll stop the monitoring. And we're doing 100 milliamps again. So the data logger was playing up then. Well, we're definitely lower with the less voltage and milliamps going into the cell. Perhaps I need to stir it up. It's settled down. Wonder what happens if I give it a stir. We'll just check it. A light stirring. That could be too long on charge, perhaps. Maybe. But it was solar power, so that's okay. We can check out my electrode at the moment. Get it under here. Yeah, see, we're forming cracks. It's sticky. Wonder if I can blend them in or something. It's probably only the top layer. It's got like a skin over it. Oh well, I'll leave that. I'll leave the lid on it so it sort of doesn't dry out as much. I'll get this one. Oh no, it does crack. Alright, won't touch it. I'll let it form. It's pretty soft under there. Alright, so I'll let this run and see what we get. I don't think it's going to be as good as the charger on it. Oh, it's not looking good for the cell. I just moved it here. I found the connection problem. It's the green alligator clip on the negative. When I squeeze it, it gets a bit tighter. You get a bit more amperage. And I can't really... Oh yeah, I wobbled it. There we go. It's just hanging on. I didn't see it. And it could be loose down in there. And don't forget that center electrode is over 4 ohms. So I think it needs a higher voltage to actually compensate for that. But I think that loose connection don't help. I reckon the alligator clip's lost its tension. Or the cell could be dead, but I'll another day I'll charge it up with the power supply and do it for 4.5 hours and see if we still get that 10 hours out of the cell. That will sort of tell us what's going on with the cell, and I don't think I'm having much luck today. My little electrode's all like shattering, but it's still pretty damp, so they might be just surface cracks. Well, the first one I made worked pretty good and came out of the mould and wasn't even looking like that, so And this one, well, don't know, maybe I made it too wet. It's quite spongy. I'm not going to touch it, it sticks to my fingers. That's what happened there. So I'll leave that and see what happens. Okay, the 7 hour on the solar cell only yielded 4 hours and 33 minutes for some reason. I think the voltage is too low to get through the resistance of the cell. I'll try later and do a normal charge on my power pack just in case the cell could be dead. So we got 456 milliamp hours and 387 milliwatt hours, and the voltage is even down 0.81 volts. So take note of the results, and then when I get back later today I'll try a 4 hour charge and see if it's the same as the other day. Alright. Okay, the cell's been on charge on the on the power supply at 3.2 volts for 5.5 hours, just to see if yesterday's run wasn't due to the cell, it was just a solar panel. And it's holding 2 volts. Start 100 milliamp test and we'll see how long it goes for. So okay, it's holding its voltage now, so it definitely is a resistance issue with the amount of volts going in. Yeah, and also 5.5 hours might be overkill, but we'll see if it runs longer than the 4.5 hour charge, which did. Where's my results? 10 hours and 16 minutes, so I'm not sure what's going to happen. So we'll just let it run its business, and I'm going to go make some dinner. The electrode's sort of dried. I've started clamping it now. You can't clamp it when it's wet, it just goes all mushy and squirts out everywhere. So you gotta wait for it to dry slightly, and tomorrow I'll probably increase the pressure a bit more, and hopefully that turns out. Oh, and that got rid of the cracks, sort of. It's compressed better and squishing it all in tightly. So a bit of luck on that one. Not sure how it's going to turn out. All my other ones failed, but they didn't have a piece of mesh in them. So far it's holding 1.7 volts, so we'll get back and see what happens. Okay, for that run, what was it? It was 5 hours and 30 minutes, so that's probably overkill on the cell because we've only got 8 hours and 59 minutes. Not quite 9 hours. So the other run was a freak run at being, what was it, 10 hours 16 minutes, and we're slightly down on our power consumption. It's 899 milliamp hours, 960 milliwatt hours, but the average voltage is slightly up. We had on the 10 hour run it was average voltage of 1.02 or 1.07 for some reason. It could have just cut out quicker, perhaps. Voltage rebound is still up. So don't know. I wonder what's going on. Maybe it shorts out in there. Too high a charge could be damaging it. It's getting some black down there now. So I think the higher charge is separating the carbon. Alright, I think I'll let it run automatically on that solar charger, and I think I might discharge it with a little motor or something when it's charged up, and then just keep testing it like that, and then bring it in every now and then and put it on the data logger and see how long it actually lasts. I'll work that out later today. Alright. Oh, I forgot to say, we made it to 1 volt for 5 hours and 23 minutes, so the voltage was up, where I think last time it went for the same 1 volt at 4.5 hours. So it's strange that it dropped quite rapidly after it hit that lower voltage. Normally it holds well. So that's an interesting fact of the cell too. Weird. Alright. Could be something to do with the conductivity in there. Hi there. I discovered what the problem is. We're on the 200 ohms range. That was the piece of stainless wrapped around the carbon, which also broke off a big chunk when I was removing it. So now it's only like that big. The resistance on the bit which is coated with the zinc is really high. If I can get these to touch. Alright, we're at 0.7 on the stainless by itself, and when I touch around depends where we land, but if we land on a piece of pretty coated stuff, it's quite high in the range. Got it on the 2000 ohm range. So we lose conductivity with the powdering of the zinc if the stainless steel is in the liquid electrolyte. So that's interesting. You've got to keep that out of the electrolyte. So I've got a new piece wrapped around there and it's out of the electrolyte. I've got it connected just then to the solar panel. So we've shot up, we've got 2 volts today on the solar panel and 106 milliamps running through the cells. So I'll keep that running. It's only been on for about 5 minutes. So I might keep that running most of the day and see if it gets a better result than 2 hours and 30 minutes like it did last time with the contaminated contact wire. Yeah. But this one didn't get in the water, so something odd with the graphite rod. It's not very porous, I don't think. Okay, I'm back. The cell's been on charge for 6 hours and 16 minutes on the solar panel, so it hasn't been consuming too many milliamps. We've made it to 2.2, it's a bit weird, maybe the sun tracking of the solar panel perhaps. It's got the new piece of stainless, so hopefully that's going to improve it somewhat. So I'll disconnect the charge and we've dropped down to 2 volts. This should tell us if the cell's still valid or not. Connecting the other end of the data logger. Okay, we're at 1.9, stopping the monitoring. We have a 100 milliamp load and doing a test. The electrode's about 10 millimeters shorter this time. Alright, we're holding 1.6, so it might be the zinc plating around the stainless might be the problem of the cell's condition the other day, and unfortunately that big chunk fell off. Alright, I'll let it run. Phone wants to do an update, of course, and I'll be back. Okay, the cell's been on for 1 hour and 11 minutes, and it just finished a smidgen under an hour and 5 minutes with 1.3 volts. So changing the stainless wire around the top and probably didn't help losing that much of the electrode, but it seems to improve its performance by not having the zinc plate around the stainless wire. And I checked the pH, that's around about 3 on the scale of the electrolyte. So we'll see how much the cell's got for a 6 hour and 16 minute solar cell charge. Okay, we're at the 2 hour mark and we're still holding 1.1 volts. That's last run yesterday with the heavily coated stainless wire with zinc. It was only 2.5 hours maximum run. So we're pretty, and and 251 milliamp hours. We're already at 211, so I think it will safely get another half hour easy on the cell, but we're minus a bit, so it's probably not going to run as long. And overcharging perhaps too, don't do that. So I might keep to the solar cell, seems to be easier, and my power supply doesn't overheat charging up the batteries, which is a win. Alright, I'll leave it for that and then I'll get back when it's done. Okay, the results are in. We got 3 hours and 47 on the solar cell for 6-hour charge. I've noticed the average voltage is getting higher on its runs, and it seems to drop straight off now instead of taper off slowly. And we got 379 milliamp hours and 431 milliwatt hours. So not a bad run. So I'll try it on the power supply and see if we improve those results with extra power in the cell due to the resistance, I think. And I'll get back with that result. Okay, I've run out of time to charge it up any longer. It's been 3.5 hours on the power supply. I'll just disconnect the power source. We should still get a slightly longer run than we do on the solar cell, due to how the solar cell's only putting in 100 milliamps. Okay, connecting. We should have voltage. Okay, we're at our 2.1 now, so it definitely holds a better charge when it's not on the solar panel. But still, solar panel's good when I'm not around. Doesn't overheat the power supply or anything like that. So, much better idea and less worry for me about catching fire or stuff like that. So, we're starting the run now. Okay, we're at 1.9 volts. So it's looking good. I made the mistake and poked it into the hole a bit too far again. Well, the electrolyte on the outside is lower than the electrolyte in the center of the hole apparently, and I only just noticed it, so I slightly coated a part of it and then I lifted it out. As you can see, that section just there is coated with zinc. I got my first electrode out. Not that happy with it. It's sort of like, looks like that. It's still a bit damp. It's about 200 ohms, but they got to go into the furnace, so I've got to wait on it to keep it flat, because in my other test samples they bowed up. And I've got a new one in there. This time I slightly made it a bit less damp, so it's more like a putty. And I packed the first layer, then put the stainless grid in, and then packed the second on top and pushed it all down and flattened it, so I don't need those bits of charcoal holding the mesh up anymore. So hopefully this one comes out a bit better. I stick that steel plate on and compress it between the two plates in a day or two when it sort of gets a bit more firmer. So we're still holding our 1.8 now, and it's looking okay, I think. So I'll get back when it's finished. Okay, just got back in. The cell's been running for 4 hours. It's 415 milliamp hours, 547 milliwatt hours with an average voltage of 1.32. So it's good that it's actually the stainless coated with the zinc, which was the issue. I was thinking it may have been also something to do with the electrolyte depleting. But seems to be holding quite well on a 3.5 hour charge it's had. So maybe 8 hours or something like that on the solar panel for the cell. But so far, 1 volt for 4 hours. Looking good still. And don't forget, we're about 15 millimeters short on our electrode now, because it broke off. So, interesting. Alright, I'll get back. Almost 5 hours at 1 volt. And he just went down. Holds quite well, the voltage. So we're probably looking at another 9-hour run, I guess. So I'll update that tomorrow. I'll let it run all night or whenever. Okay, let's see our results. We got 7.5 hours out of it. 765 milliamp hours, 851 milliwatt hours. So not a bad run. So the cell's still pretty valid, but I'll try it on solar cell all day today and see what happens. I'll turn the laptop off and give it a rest, so I won't data log it, but we'll see what we get. Alright, till then. Okay, we're sitting at 1.8 volts. It was charging on the solar panel for 8 hours and 11 minutes, and we'll start a 100 milliamp load. So it's holding at 1.8 quite well. And starting. Alright, so we're not as high. It was, I think normally it goes like 1.6 when it's on the charger, but the light may have dropped down too much outside, and I'm not sure if the solar cells start to drain the cell or just trickle charge or something. I wasn't logging the charge this time. I had the computer off because I will just leave it on now and see what the results are. Alright, I'll get back when it's done. Okay, it's been running for 20 minutes. We're still holding 1.3. It's not as good as being on the power supply for some reason. Amount of milliamps going into the cell perhaps, but we'll probably get like 4 hours, hopefully more. So be the last update and going out, so I'll see you when I get back. Okay, after 8 hours on the solar panel, only 4 hours and 43 minutes. Not a bad run though. It's always down for some reason on the solar panel. And we're 473 milliamp hours and 511 milliwatt hours and an average voltage of 1.08. It's a bit down. It's normally 1.11 or 1.4. Yeah, so there you go. Alright, I'll be back later. Okay, what you see here is the 18th discharge of the all carbon cell version. It's holding 1 volt for 5 hours now. It's at 501 milliamp hours, 662 milliwatt hours, and the charge was 3 hours and 53 minutes. So the cell's still functioning even though I've lost that much of the what was it? The negative electrode when I changed that over, because if the stainless contact goes into the electrolyte, it becomes really high in resistance, so you got to keep that one out of the water for the negative side. And I've sort of got it coated again, sort of it seeps up there a bit. So I've been slowly charging it every so often, and it's still holding performance. To overcome the resistance, I just put it up to 3.3 volts. For 3 hours and 53 minutes, and it seems to work without replacing the stainless. I deleted some videos because this one was going to get too long, and in the meantime I've been making, I've got 6 of these little electrode plates. They're about that thick. They're about 100 ohms, about 50 millimeters apart. I use dextrin as the binder, and they got to go into the furnace on the next spare day of 5 hours at 1000 degrees, and hopefully that should bind them together and make them waterproof and not powdered. Hopefully not. Anyway, hopefully they stay the same form, and yeah, so I'll work on that bit and let this thing finish its discharge. The voltage really seems to be holding strong now on the cell. Doesn't sort of drop as quick. And the average voltage is way up now. It's 1.32 volts average. So it's probably got another 4 hours in the cell, or maybe a bit more, to our cutoff voltage, 0.5, like we've been doing. I'm keeping the results, it's not been too bad. Depending on the charge, it doesn't like the low voltage solar charge. It's got solar here. I charged it for 4 hours, or only 147 milliamp hours in 1 hour and 28 minutes. I think it's got a lot to do with the high resistance on the cell. Because as soon as you connect it to the power supply and charge it at 3.3, it sort of has no problem. It holds its voltage really well. And I've just added distilled water to top it up because it evaporates out over, I think it's been like 3 weeks or more since I put the double carbon into it. Alright, this is getting a bit long, so I'll get back after I fire them up. Okay, the cell's still got it in it. 10 hours and 13 minute runtime and 1021 milliamp hours and 1099 milliwatt hours. Not bad. And recovery time was overnight, so it's 1.1, holding quite strong. Alright, there you go. Okay, today's the day I'm going to furnace the carbon electrodes I made. This was the first one. That was the sort of like a resin mix, so it didn't turn out so well. It's a bit cracky. I got the resistance on 200 ohms, and that one's about 120, say, ohms. That was the first one. It's a bit thinner than the other ones. It sort of works a lot better when you make a putty and press it into the mold and then bake it at 130 degrees for 4 hours. So that one's got 97. We can't use them as they are because the dextrin is not waterproof. It will dissolve. So I'm going to put them in the furnace at 1000 degrees for about 5 hours and see what we get. Hopefully the resistance comes down and they bind. They should sort of turn out to be like those other cells we have there. So I'll set it all up in the furnace and get ready for a burn. I got 6 of them. I've just started the 9/8 run on the all carbon cell. It had 4 hour charge at 3.7 volts this time, just to see what's happening. It's overkill, but I think the resistance in the cell's pretty high at the moment because of the stainless wires being coated in zinc again. But it seems to be holding its voltage well, so we'll see if we get another 10-hour run. So I'll be back. Cell's been running for 1 hour, holding 1.4 volts already. So at 100 milliamp hours and 171 milliwatt hours. Still looking good. Okay, 2 hours into the run, we've only dropped 0.5 of a volt, or just under really, in an hour. So the cell's actually holding quite well for a 100 milliamp load on it, and how it's crudely constructed, it's not too bad. So it's looking good. Okay, 3 hours and 6 minutes run time, 310 milliamp hours, 443 milliwatt hours, and again, just under 0.1 of a volt drop, not even that yet, in an hour. So we're looking at our 10 hours, I think, again, going by this. 4 hour update, and the cell's holding strong. Still 1.1 volts and not dropping so quickly. It's actually holding that. So we're on schedule. 407 milliamp hours and 558 milliwatt hours. Average voltage 1.37 so far. We've got our charge time back, and I've got the furnace going for 5 hours now. It's been. It's cherry red hot, the crucible. So So hopefully the electrodes haven't fallen apart. Bit of luck. Hope they hold their shape. It'd be disappointing. 5-hour update on the cell. We're still at 1 volt. We may get 5.5 hours at 1 volt. Maybe. We might be pushing it to get 6. I don't know. We're 508 milliamp hours, 668 milliwatt hours, and an average voltage of 1.32. Holding well. I just turned the furnace off, so it's been running for around about 5.5 hours plus 20-minute warm-up time. Hopefully tomorrow I'll get to see if the cells are intact. Bit of luck. I hope they are. I cooked some more of the redhead carbon as well, so I can prepare some more if everything works out. I lined it sort of and put the redhead against the other cells. So a bit of luck. Okay, not sure if we'll get to 6 hours. It's 1.002. Oh, it's gone up. 4. Down to 2 again. Volts. We've got 8 minutes or 7 minutes now. Yeah, about now. 7 minutes. Alright, I'll get back. Okay, we didn't quite get our 1 volt at 6 hours, but we're close to it, which it's an improvement anyway on the cell. We're 604 milliamp hours, 766 milliwatt hours. So we've probably got another 4 hours at least in run time. It's holding quite well. We could probably push the center electrode in, but I'm not going to do that. And probably bump it up, but we'll leave it as it is so we don't touch it. And I'll get back with the results. Okay, we're at 7 hours run time, 0.9 volts, 714 milliamp hours and 870 milliwatt hours. Average voltage is 1.22. So it's probably at least got another 3 hours easy, so it would make 12 hours. Oh, I mean 10 hours, I was counting a little 0.9, don't worry about that. Yeah, alright, so we get 10 hours easy, I think. Well, we'll see anyway. Okay, let's see what we got for the run of the battery. Oh yeah, we got 10 hours and 53 minutes, not a bad run. It's 1087 milliamp hours, 1151 milliwatt hours, average voltage of 1. And we got a bounce back of that overnight. So not a bad run. Alright, I'm going to go check the furnace now. The refractory failed, I noticed it was crumbling, so we exceeded 1100 degrees. Okay, that's the top of the furnace. The calcium aluminate sort of failed. Top layer's come off. Big chip of it came out there. That's how thick it was. That was just straight calcium aluminate. And same deal around. But that's holding up. It's a bit flaky. So we must have exceeded 1100 degrees for that to do that. And now I'll pull that out. I've got it sealed up. And we'll check the electrodes. Fingers crossed. Okay, so far the electrodes look like they withstood the furnacing. They're the same shape. This first one, where I used that bit of carbon in there, fell out. So that other piece where I supported the grid, it's held up, feels a lot different. Also I surrounded it and supported the plates with the other redhead briquettes. So we'll check the resistance on them. We've got the meter set to 200 ohms. And we're down to 1.5 ohms. Yep, 1.5 ohms. Try another piece. That one's slightly higher. Yeah, 2. Alright, we'll try our plate. We'll spread them out. Alright, we're still better than we were. We were like 100 and something on that first piece. We're 2.4. That might get better when I chisel away and free the stainless gauze inside. This one, we're 1.6, 1.5 ohms over that distance, 1.4. That's not too bad. Try the other side. Oh, it's a bit soft. 2.3, 4, 3. Not too bad. 1.7, 6. .8 ohms, not too bad. So they're looking good. Oh, piece broke off over there. So they still may fail in the liquid. 1.3 on that one. That one's held together really good. That could have been slightly drier and pressed better. This one seems to be flaky. 1.4 ohms. So far, not too bad. So we'll see how they go in the cell. Alright, I'll put that on another video, and thanks for watching.